Today we are going to start with coordinate geometry. Let me just write the chapter name. So why do we actually use this coordinate geometry, or what does this coordinate geometry actually means? This coordinate geometry, it is all about connecting the algebra with geometry. It consists of the two things. It helps you to connect the algebra with geometry. So instead of only drawing the shapes, we describe the geometric objects using numbers and equations in coordinate geometry. So it's all about understanding the shapes using numbers and equations. So how does this coordinate geometry works? It all depends on the coordinates. In coordinate geometry, every point, what do we mean by coordinates? Every point on a plane, it is represented by two numbers which we call as coordinates. So to show the position of every point on a plane or on a grid, we use two numbers which we call as coordinates. For example, if I have a point A, I can tell its position along the x-axis. I can locate the exact position of this point A on the grid or on the plane by telling its position along the x-axis, which is x coordinate, and then its position along the y-axis, which is gonna be y coordinates. This is what we mean by coordinates. For example, if I'm given, this is the general representation. Now I say that, for example, I'm given a point A and it has the coordinates 2 and 3. We can simply locate them on the grid. So it should be at position 2 along the x-axis and at position 3 along the y-axis. So it should be like here. This is the exact position of point A. So this is how coordinates actually help us to locate any point on a plane or on a grid. So this is the horizontal axis, this is the vertical axis that we have got, and this point where they intersect is the origin, and the coordinates of the origin, they are always 0 and 0. So coordinates, they simply tell you that how far we have moved horizontally and how far we have moved vertically. Now if we look at the quadrants, we know that this is the quadrant 1. For example, like this is the quadrant 1, then we have quadrant 2, then we have quadrant 3, and this is gonna be quadrant 4. So both of the coordinates, they are positive in the first quadrant. In the second one, the x coordinate is negative and the y coordinate is positive because this is along the positive x-axis. In the third one, both of these are negative, and in the fourth one, x is positive and y is gonna be negative, like this. Now if we only look at any point, for example, we are given this point and its coordinates are -5 and 2. Just for looking at the digits, we can tell that the first one is a negative and second one is positive, so it must belong to quadrant 2. Then the second basic concept that you need to know is that you should know the difference between the term plotting sketching and drawing. So plotting is quite simple. It simply means marking the exact points using the coordinates of a point. So this is simply the representation of the points using their coordinates on a grid or on a plane. Exact points location. Exact points location. Can you tell me the difference between sketching and drawing?
Mm. Sketching is like rough lines, and then
Yeah,
drawing is like one singular line.
very good. Sketching is drawing roughly, and drawing is creating a precise and accurate diagram using the coordinates. And this is just simply rough graph, and drawing is what we say. It's a precise diagram. Okay. Now, if we say, for example, we are given the coordinates, one is point A, we are given 3 points. One is 1, 2, point A. Then we have got the point B, which has the coordinates 4 and 2. Then we get point C with the coordinates 4 and 5. And we are asked to draw it. We simply have to do the plotting first. So it is 1, 2, 3, and 4. 1, 2, 3, 4, and 5. We will simply plot it. It is 1, 2. Then this is 4 and 5. And it is 4 and 2. And we will use a ruler to just simply connect them together, and we will get a triangle. This is just a simple intro to this chapter. Then the first main thing that comes in the chapter, it is about finding the gradient of a line. Gradient of a line. By gradient, we mean the slope of a line. For example, we are given 2 points and they are connected together by a line. The gradient of that line, for example, these are point A and point B. The gradient of this line, it will help you to tell that how steep the line is. The gradient, which is also called as the slope, it helps you to tell the steepness. So it helps you to tell that how steep the line is. And in other words, you can simply say that it helps you, or it tells you the rate of change of y with respect to x. Rate of change of y, that how much change will occur in y-axis for each change in x-axis. Like if I move 1 point along the x-axis, for example, it is at point 2 and I move to point 3. So how much change will occur in the y-axis? This is what this gradient tells. It tells you the rate of change of y with respect to x. Okay, for example, if we have we usually represent the gradient as m, the gradient of any line. For example, this is the line which has points A and B. I will show the gradient of this line as m with the subscript a b. It represents that I am writing the gradient of the line AB. So whenever you get a positive slope, like whenever the value of m is positive, the line will be rising. The line will be something like this. It will be rising. Whenever you get a negative slope, the line will be falling like this. And whenever you get a zero slope, your line will be simply a horizontal line. There will be no change in y-axis. That's when you will get the slope as 0. So the formula that we use to find the slope or the gradient is simply m is equals to y2 minus y1 divided by x2 minus x1. And we know that x2 and y2 are the coordinates of the second point, and y2, y1 and x1 are the coordinates of the first point, and x2 and y2 are the coordinates of the second point. This is quite simple. Let's just go through it quickly and then we will move towards the exercise. So for example, we are given 2 points. One is point A. It has coordinates 1 and 2, and then we get point B, which has the coordinates 3 and 6, and we are asked to tell the gradient, to find the gradient or the slope for these 2 points. For example, if we plot them and we join them with a straight line, we have to find the gradient of that line AB. So we will do M, and you can write AB, and then you can simply subtract it. This is second point, so we will subtract the y coordinate of the second point minus the y coordinate of the first point divided by x coordinate of the second minus x coordinate of the first. This is gonna be 4 by 2, which is equals to 2. So it actually means that for every increase of 1 in x-axis, y will increase by 2. This is what it means. For example, if I plot them over here, for every increase of 1 in x, for example, this is at point 2 along the x-axis, and I move to point 3 along the x-axis. For every increase of 1 in x, y will increase by 2. This is what it means. Got it?
Yeah.
Okay. So for every increase of 1 in x, y increases by 2. Okay, so for example, we get some points where we also have the negative coordinates as well. For example, this one, and point B is 5 comma minus 3, and we are asked to find the slope of this line. So it will be simply minus 3. You have to subtract this one, the y coordinate of the first one, then we will subtract y, the x coordinate of the second point, which is 5, minus, this is minus 2, so minus minus, it will give you plus 2, and it will simply become minus 7 by 7, and it will be minus 1. So this negative sign, it tells us that the line's slope is downward. Slope is falling, or it's downwards. So it will be something like this. It will be falling. Now, the next thing that you should know before moving towards the exercise is that how do we find the distance between 2 points? Okay, so for example, we are, let me draw a triangle to make you understand it better. For example, we are given 2 points, it's 2, 4, and 6, 7. For example, we are given 2 points. This is point A, this is point B. It has the coordinates 2 and 4, and it has the coordinates 6 and 7, like this one. But I will do, this is point A and this is point B. I want to find the distance between these 2 points. I will join them with a line. Now I want to find the distance between them. What I will do, I will extend it along the horizontal, like the distance between them, between these 2 points. First, I will extend it along the horizontal, like this, and then we will extend it along the vertical. So at this point, you can see that we are getting a 90-degree, a right angle over here. Now, if we look at only the distance along the horizontal over here, the x coordinate has the value 2, and at point B, its x has the value 6. So along the horizontal, how much did we travel? We moved from point 2 to point 6. So it was 6 minus 2. So it means that the length of this horizontal line, it must be 4 units or 4 points. Similarly, we will find the length of this side as well. So the y, it had the value 4 at for point A. The y coordinate, it was 4. So to move from this point only along the vertical, I'm only talking about the vertical. So at this point, the value was 4. 4. So to move from 4 to point 7, how much did we travel? We traveled 7 minus 4. This is going to be 3. So if we look at this one, the diagram, we can see this is a right angle triangle. Now we have got the values for both the sides of the triangle, and we want to find this side. So to look at the diagram, we can see that this side, it is the simply the hypotenuse, and we know that this is a right angle triangle, so we can apply the Pythagoras theorem on it. So we can write that hypotenuse square will be equals to the sum of square of both the other sides. So it will be 3 square plus 4 square. This is gonna be hypotenuse square equals to 3 times, it will give you 9, plus 4 times give you 16. So it will be 25. So this 25, it is equals to the hypotenuse square, not the hypotenuse. Now to find the hypotenuse, the length of this AB, we will take the square root on both sides. So we will be left with hypotenuse equals to 5. So this is how we find the distance between any 2 points. First we make a triangle, and then we calculate the distance or the units that we traveled along the x-axis, and we travel the units that we traveled along the y-axis, and then we apply the Pythagoras theorem on it to find the hypotenuse. So to generalize it, we have derived a formula. This is what we do. You can see that what did I do? To find these two sides, first I subtracted the x coordinates of both the points, and then we took a square of these. First we subtracted them, so it will be x2 minus x1. Then we took a square of it, and we added the value that we got for the change along the vertical. So this 3 we got as by subtraction of the y coordinates of both the points. So it will be y2 minus y1 whole square. Then we take a square. Then we add them both, and at the end we take a square root. So this is how we find the distance between any 2 points. This is the formula that we use, and this is the derivation. This is the logic that where did we get this formula from. This is the reason behind it. So now if we practice a question, for example, we say we are given a point A. It has the coordinates 1 and 2, and then we have another point B, and it has the coordinates 4 and 6. We have to find the distance between these 2 points. We will simply do the distance equals to square root of 4 minus 1. It will give you 3 square plus 6 minus 2. It will give you 4 square. So it will be equals to 9 plus 16 equals to 25, and the distance will be 5. Okay, then you should know that how do we find the midpoint of a line joining 2 points. For example, we are given 2 points, they are joined with each other, and we with a line, just like we do in this case where we are given 2 points, we simply plot them and draw a line between them to connect them. So when we join them with a line, we want to find the midpoint of that line. So this is where we will use the next formula, which is finding the midpoint of a line joining 2 points. So we know that midpoint, by midpoint we mean the point that is exactly halfway. The point that is exactly halfway between those 2 points. Okay, so the formula that we use to find the midpoint is we simply add the x coordinates of both the points, and then we divide them by 2 to get the midpoint. Similarly, we do with the y coordinate. So this is going to be x1 plus x2 divided by 2 divide comma y1 plus y2 divided by 2. So for example, we are given 2 points. One is point A and this is point B. And for example, its points are, there is only change along the x-axis. There's no change along the y-axis. So its points are, for example, I say that they're 2 and 4, and its points are 5 and 4. So I want to find a point which is present in between these 2 points. So if it was at along the x-axis, if it was at point 2 and it was at point 5, I want to find the midpoint of those two. So we know that to find the middle of 2 plus 2 and 5, I simply have to add them and then divide them by 2. So 5 plus 2 will be 7. Divided by 2, it will be 3.5. And there should be no change along the y-axis because the line, it lies on the along the horizontal. It is not changing. So you simply add the y coordinates. It will be 4 plus 4, 8 divided by 2, and you will again get 4. This is how we find the midpoints. If we see that, for example, we are given 2 points and we are asked to find the midpoint, we are given point A, which has the coordinates -3 and 5, and then we are given point B, which has the coordinates 7 and -1. And we are asked to find the midpoint. To find the x coordinate of the midpoint, we simply add the x coordinates. So it will be 7 plus -3 divided by 2. It will give you 2. And same thing we do with the y coordinate. It will be simply y minus 1 divided by 2. And it will be 4 by 2 will be again 2. So our midpoint, it will become 2 comma 2. Both the coordinates will be 2. Now let's move towards the exercise. This is all that you need to know. Let's just move towards the exercise. Okay, question 1 is quite simple. In this question, you are only asked to find the gradient of a line, the midpoint of a line, the distance between those 2 points, and the gradient of the line perpendicular. Yes, there is one more thing that you should know. This is about the gradient of a line perpendicular to a line. Gradient of a perpendicular line. For example, I am given a line which is line A and B. These are 2 points. I am given this line A and B. And let's say I calculate its slope or its gradient and it comes 2. Then I suppose that I am given another line which is perpendicular to this line. So perpendicular means that it must be making an angle of 90 degree with this line, and it can be drawn at any point. It can be drawn at this point, this point, this point, this point, at any point. But the only condition is that it must be making an angle of 90 degree with this line AB. So let's say I draw it at this point and it is making an angle of 90 degree, then we call it as a perpendicular line. So for example, if I am given the gradient of the original line, which was AB, so if its gradient was 2, I can simply tell the gradient of a line that will be perpendicular to it without calculation. If the gradient of the line AB was 2, the gradient of this line, which is perpendicular to the line AB, it will be simply the negative reciprocal. Negative it will be the negative reciprocal of line AB. So if line AB had the gradient m, for example, I name it as CD. So if AB has the gradient 2, line CD, it will have the gradient, the negative reciprocal of it. If it was 2, the negative reciprocal of 2, it will become -1 by 2. So you don't even need to calculate it. You can simply tell the gradient of a line perpendicular to it, and whenever two lines are perpendicular to each other, when you multiply their gradients, it will always come equal to -1. So you can see that these two are perpendicular to each other, so the slope or the gradient of AB multiplied by the slope of CD, they will always give you -1. So if you look at this, you can see when I multiply 2 with -1 by 2, I will get -1. So it means that these two lines, if you are given only the gradients and you are asked to verify that whether these two lines are perpendicular or not. What you can do is this: you can simply multiply their gradients, and if the answer it is equal to 1, then you can tell that the two lines, they are actually perpendicular to each other. So this is all that you need to know. And now we can finally move towards the exercise. So this one is actually quite simpler, but let's take one example so that you can solve it yourself. So let's take 5, 2, and 2 and minus 8. For example, we are given 2 points. We are given point A, it has the coordinates 5 and 2, and then we are given another point B, which has the coordinates 2 and minus 8. And you have to find, first you have to find the gradient. Then you have to find the midpoint. Then you have to find the distance. And in part D, you have to find the gradient of a perpendicular line. This is all that you have to do. Yes, can you try it? Okay.
The gradient is 5.
The gradient is 5. Is it 5? Let me just. It's 3A and question 1. It's not 5, I guess. No, it's not 5. You have to simply do y2 minus y1 divided by x2 minus x1. So minus 8 minus 2, it will give you minus 10 divided by x2 minus x1, it will give you 2 minus 5, it will be minus 3. So your gradient will be minus 10 divided by minus 3. So minus will be cancelled by minus and you will be left with 10 by 3. It's not 5. What about the midpoint?
1 second. $10.4.
10.4? 10.4. How do we calculate the midpoint? You simply add the x coordinates and you
Oh
divide.
wait, yeah, I did it wrong. 1 second. Sorry, I accidentally counted the distance.
Yeah, this is the difference. There's a difference between midpoint and distance. So what will be the midpoint?
-3. 7/2. No, wait, I messed up. 1 second. Let me do it again. Oh yeah, 7/2 minus 3.
Yes, very good. It will be 7 by 2 and will be minus 3. Now you have to find the distance.
Distance was 10.4.
10.4, okay. And then you have to tell the gradient of a line that will be perpendicular to this line.
It'll be minus 3 over 10.
Yes, very good. It will be the negative reciprocal of the original line, so it will be minus 3 over 10. Okay. Now if we move to the next question, it says that we are given the line joining the points. You are given 2 points. Point P, it has the coordinates 3 and minus 4, and Q has the coordinates Q and 0. It has a gradient of 2. You have to find the value of Q. Okay. So we are given 2 points. One is point P. It has the coordinates 3 and minus 4. And point Q, it has the coordinates Q and 0. And you are given the gradient for this line, which is joining point P and Q. Its gradient is 2. We have to find the value for Q. How will we find that? What will be the answer?
1 second. Half. Minus.
No? You are given the gradient, right? So you will simply use the formula for the gradient. We know it's m is equals to y2 minus y1 divided by x2 minus x1. Over here we are given the gradient, and one thing that is unknown is the x coordinate of point Q. So it is x1. Now we will simply substitute the values. So we know that the gradient is 2. It will be 2 equals to y2 is 0 minus, it is negative 4. X2 is the x coordinate of the second point, which is Q, which is Q. Then you subtract the x coordinate of the first point, which is 3. So it will become 2 equals to 0 plus 4 divided by Q minus 3. Now we can simply move it there by cross multiplication. So it will become 2Q minus 3 equals to 4. And then it will become Q minus 3 equals to 2. If you divide the complete equation by 2, so it will become 2, and then Q will become equals to 2 plus 3, which is gonna be 5. So its value is 5. Clear? Now if we look at the next question, we are given 3 points. This time one point is point X, point Y, and point Z, and they are collinear. It means that they lie on the same straight line. We have to find the value of one of these coordinates. Okay, so the next question, we are given 3 points. One is point X. Its coordinates are 2 and minus 1. We are given point Y. its coordinates are 8 and small y, and the third point is C and its coordinates are 11 and 2. All of these are collinear points and we have to find the value of this y. Collinear. What do we mean by collinear points?
Mm,
The points that lie on the same straight line. For example, if I am having a line like this, so they will lie on the same straight line like this. So whenever they are collinear, whenever all the 3 points they are collinear, you can say that the gradient of these 2 points, it will be the same as the gradient of the other 2 points. For example, if x lies on the bottom, then we have y somewhere in between, and then we have z on the top. We can say that as they are on the same line, so it means that their gradient must be same. So it means that the gradient of the first 2 points, like the gradient of xy, it will be equal to the gradient of yz because they are collinear. Whenever the points are on the same line, because we know that the gradient of one line, it is the same. So the gradient between any 2 points that will lie on that line, it will be the same. So we will use the condition that the gradient of the line xy, it will be equal to the gradient of yc. Now how will we calculate the gradients? How will we calculate the gradient of xy? If we look at this one, we know that it is y2 minus y1, so it will become the gradient of xy, it will be y plus 1 divided by, it's 8 minus 2, it will give you 6. It must be equal to the gradient of the gradient between the next 2 points. So now we want to find the gradient between yz. So it is 11 minus, first you have to subtract the y1, the y coordinates, so it will be 2 minus y divided by the subtraction of x coordinates, which is going to be 11 minus 8, so it will be 3. Now we can simply cross multiply them. So what answer are you getting by solving it further?
wait.
Okay. You can cross multiply it. You can even multiply the whole equation by 6 to simplify it. You will be, if I multiply the complete equation by 6, I will be left with y plus 1 equals to 2 times into 2 minus y, because the denominators will get cancelled by 6. If I multiply it by 6, it will be cancelled. And if I multiply this by 6, it will give me 3 1 times and 3 2 times 6. So it will become 2 into 2 minus y. So it will be simply y plus 1 equals to 4 minus 2y. And then it will become 3y equals to 3. And y will become equals to 1. So this is the value that we needed to find for y. Okay, if we look at the next question, we are given the points. We are given 4 points. One is point A, B, C, and D. And the coordinates for each of these points are given. You are asked to find the gradients of the line AB, BC, CD, and DA. And then you are asked that what do these gradients tell you about the quadrilateral ABCD? And then you have to draw a diagram to check your answer of part P. Okay, let me write the points along with their coordinates. So we are given 4 points. One is point A, it has the coordinates 1 and 2. Then we get point B with the coordinates 7 and 5. Then we get point C with the coordinates 9 and 8. And then for point D, the coordinates are 3 and 5. We are asked to find the gradients for AB, for BC, for CD, and for DA. First you have to find this, and then you have to tell that what information do you get just by looking at the gradients. First you can simply find the gradients of each of them.
They're all parallel?
All of these?
No, wait, no. The gradient of BC and the gradient of DA are parallel.
Very good. BC and DA are parallel, and what's the value?
2/3.
2/3 or 3/2?
Oh yeah, sorry, 3/2.
So this is 3/2, and this is also 3/2. What about the other two gradients?
-1/2 and 2.
-1/2 and 2. Both of these are 1/2. Right?
Okay.
Why? You can recheck. Both of these are 1/2. Just like we know that the slopes of perpendicular lines, they are negative reciprocal of each other. Similarly, the slope of two parallel lines, they are always equal to each other. So if this is line AB and this is line CD, and if the slope of line AB it's 2, we can see that CD is also parallel to it. So the slope of CD, it will also be 2. So for two parallel lines, the slopes are always same and equal. Slopes are equal. So we can see from the gradients that opposite sides, they have got equal gradients. Like AB has the same gradient as CD, they will be opposite to each other. If this is A, this is B, this is C, and this is D, for example, then AB and CD, they are like opposite to each other. They will be parallel. So their gradients are same. It means that AB and CD, they are parallel to each other. Similarly, BC and DA, they are also parallel to each other. So we can see that the opposite sides, they have the equal gradients. This is A, this is B, this is C, and this is D. So they will be parallel to each other, and the other two, they are also parallel to each other, but they are different than these two. Then A, B, and C, D, they are same with each other. It means that they are parallel to each other, but they are different than the rest of the two, than A, B, and C, D. So it means, what do we mean by that? We can write it as that AB is parallel to CD and BC is parallel to AD. So we can say that whenever we have the opposite sides that are parallel to each other, we say that the figure, the quadrilateral ABC, this is a parallelogram. You can even draw it to verify. Okay, so in the next question, we are given 3 points and their coordinates. One ABC, 3 points, and their coordinates are A has got the coordinates 2 and 1. B has the coordinates small p and 3. C has the coordinates 5 and 5. Where B is greater than 3, and you are given two conditions that B is greater than 3 and the angle ABC, it is 90 degrees. Okay, so you are given this piece of information that B is greater than 3 and ABC is angle ABC. It's equals to 90 degree. Okay, so in the first part, you're asked to find the value of P. You have to find the value of P. How will we find the value of P? Using this information that is given.
Mm,
You are given the angle. It means that it must be of some use. You have to utilize it. Why should be any angle given to you if it is of no use?
that
So,
could be a right angle triangle.
um, yes, you don't have to think about a right angle triangle. You right now we are simply discussing the concepts of midpoint, the gradient of a perpendicular line, the gradient of a parallel line, midpoints, and the distance formula. Right now, over here we can see that we are having a 90 degrees of angle at point P, at point B. So it means that this point B, it is having a 90-degree angles. What does that mean? This is point B, this is point A, and this is point C. So what does that mean? It means that the gradient of line AB, these two lines, they are perpendicular to each other. So using this information that is given, that B is having a 90-degree angle, we can see that line AB, it is perpendicular to line BC. So we know that any two perpendicular lines, when we multiply their gradients, we get -1. So we can simply write, using, we only used this angle which was given in the question, and from here we concluded that the slope of line AB, when we multiply it by the slope of side BC, we should get -1, like this. Now we can simply find the gradients and then we will substitute them into this rule. So we know that the gradient of point that the gradient of line AB, it will be for these 2 points. So it will be 3 minus 1, it will be 2 divided by the subtraction of the x coordinate, so it will be b by b minus 2. This is the gradient for line AB. Now if we want to find the gradient for line BC, it will be this, we will calculate it in the same way. So it will be simply 5 minus 3, it will be 2 divided by 5 minus b. Now we have got the values and we will simply put them into this rule that when we multiply them we should get -1. So we will now simply multiply them, put the values in equation 1. So it will be 2 divided by b minus 2 multiplied by 2 divided by 5 minus b equals to, we must get -1. Now we can simply multiply them and we will be left with b minus 2 and 5 minus b, and it will be equal to -1. Then you can move these terms on the other side and it will become minus into b minus 2 and 5 minus b. You can simply expand them and it will become 4 equals to, it will be minus b multiplied by minus b, it will give you b squared. Then it will be plus 2 times 5, it will give you plus 10, and then it will be plus 2 times minus 6, it will be minus 12, or you can multiply them first because I guess we are not getting the, it will be 5b, so it will be minus b squared, then it will be minus 10 plus 12, like this. So it will be 4 equals to minus 5. This is not 6 actually. This is b. So when you multiply it, you will get minus minus plus 2b, not 12. So it will be 5b plus 2b, it will give you 7b minus b squared minus 10. And now you simply multiply it by minus and it will become b squared minus 7b plus 10. You can convert it into the standard form of a quadratic equation and it will become, you simply move 4 on the other side, so it will become plus 6 equals to 0. Now we can simply factorize it, so we can make the factor 6 and 1, so it will be minus 6b minus b plus 6 equals to 0, and you will be left with b minus 6 and minus 1 into b minus 6, and we will get the factors b minus 1 and b minus 6 equals to 0. From here we are getting two values. One is b is equals to 1 and the one value is b is equals to 6. But in the question we were given the condition that b must be greater than 3. It was given in the question. So we will only consider the second value, which is b is equals to 6. We will discard the first one because of the condition that is given in the question. So this will be the value for b, right?
Hmm.
Do you have any questions?
No.
Okay, then see you tomorrow at 9 a.m. Take care.
Okay.
Allah Hafiz.
Allah Hafiz.